Okay, in this question we are looking at using the sine cosine rules and the area of a triangle. Now we have here a triangle that's given. They describe here in the question what information is really shown in the diagram. I've just added the convention of labelling the sides lowercase a, opposite angle A, lowercase b, opposite angle B, and so on. All right. And we're asked to find the exact area of the triangle ABC. Okay, so we're not finding a decimal approximation. We're leaving the answer, if necessary, as a surd. Okay, so let's make a start on question A. And we're going to use the fact that the area of any triangle is a half times two sides multiplied together times the sine of the angle between them. So it's a half AB sine C, okay, which is a half of 5 times 4 times the sine of the angle between them, okay, and that's sine 60. Now, if you work that out, it's obviously half of 20 is 10, so it's 10 times the sine of 60, okay, and the sine of 60 is 10 times root 3 over 2. Okay, and I'm going to show you in a moment how you can see that it's root 3 over 2. And 10 root 3 over 2 is obviously 5 root 3, and the question is in centimetres, so it's 5 root 3 centimeters squared. Okay, so roughly speaking, root 3 is about 1.7, so this is about 5 times 1.7, 8.5 centimeters squared, so it seems about right. Now, if you're not sure why the sine of 60 is root 3 over 2, you need to learn that and understand where that comes from. So here's an explanation. This is, or was, an equilateral triangle that's been cut vertically straight down the middle. Originally, the side lengths were 2 centimeters, so this length across here is now 1 centimeter because it's half of what it originally was. And this is a right angle because it's a perpendicular line straight down the middle of the equilateral triangle, and this of course is 60 degrees here because that's the interior angle of an equilateral triangle. So the sine of 60 is the opposite over the hypotenuse, and to find the length of the opposite we can use Pythagoras Theorem. So the length of this vertical line here is, from Pythagoras, the square root of 2 squared minus 1 squared. So the square root of 2 squared minus 1 squared is the square root of 3. Okay, because it's the square root of 4 minus 1. So it's the square root of 3. So the vertical height of that triangle, that's from top to bottom there, is root 3. Okay, which I've already said is about 1.7. So from that diagram you can clearly see that the sine of 60 degrees is root 3 over 2. Okay, and you can also see that the cosine of 60 degrees is 1 over 2, which is a half. Okay, and from this you can also get the sine and cosine of 30 degrees and the tangent of 30 degrees as well, and 60 degrees. But that explains how I knew it was root 3 over 2. And that's the exact answer that they required. Okay, now question B, show that AB equals root 21 centimeters. So they're giving you the answer. You've got to show the steps that lead to that answer. So they're saying that the length of this line, C, is root 21. Okay, well, what I'm going to use here is the cosine rule, and I'm going to say this. Let me just write it here. So for question B, I can say that c squared equals a squared plus b squared, which is 5 squared plus 4 squared, okay, minus 2 lots of 5 times 4 times the cosine of the angle that's opposite the side we want. Okay, so it's a very straightforward substitution into the formula. Now, it is the case, as I've just described, that the cosine of 60 from this triangle is a half. So I can do this without any calculator. I can say that c squared is equal to, well, it's 25 plus 16, okay, minus 2 lots of 20, which is 40, and 40 times the cosine of 60 is the same as 40 times a half. Okay, because we've just explained that the cosine of 60 is adjacent over hypotenuse. And I can work all that out, and I should find that c squared is 21, because c, the length c, in other words the length of AB, they're telling us is root 21. So hopefully this comes to 21. So c squared equals 25 plus 16, which is 41, minus half of 40, which indeed makes 21. So if c squared is 21, then it follows that c equals root 21. Okay, so we've shown that to be true just by substituting carefully those numbers into the correct places in the formula for the cosine rule. Okay, now for part C, it says find the value of sine, I'll do it down here, of angle ABC. Okay, so they want the sine of angle ABC in the form k root 7, where k is an exact fraction. Okay, so what angle are we talking about? We're talking about the angle here, which is the angle B. Okay, so instead of calling it the angle ABC, because there's only one angle here at B, we can just refer to it as angle B. All right, so what I'm going to do is say that using the sine rule, that sine B, okay, that's what I need to find, divided by 4, that's the length opposite, okay, is equal to, so it's like sine B over B equals sine C over C, which is equal to sine 60 over C, and we know C to be, that's lowercase c, to be the length root 21. Okay, so I'm basically using sine B over B equals sine C over C. And I just have one unknown in there, which is B. So I've just got to rearrange that, or sine B rather. And therefore, from that, I can say that sine B equals 4 times sine 60, okay? 4 times sine 60 over root 21, okay? But I've already said that sine 60 is root 3 over 2. So I can tidy that further by saying it's 4 times root 3 over 2. But because I'm also dividing by root 21, I can put the 2 underneath with the root 21. Okay, and I'm going to create a third expression, and let's just finish that off. So we have now, okay, 4 over 2 is 2, and root 3 over root 21 is the same as root 3 over 21, which is root of 1/7. So it's 2 times the square root of 1/7, okay, or 1 over root 7, perhaps I should have written. It's the same thing, but it's easier to see what we're going to do next. So I'll just take out that root and just write it as 2 times 1 over root 7, so 2 over root 7, okay, and then I'm just going to multiply top and bottom by root 7 over root 7, which rationalizes the denominator, okay, and that gives me 2 times root 7 over 7. Okay, but I'm going to put the 7 there because it said write it in that form where k is an exact fraction. Okay, so k is 2/7, and that's the answer. Okay, and just going back to this, I proved that I don't need to put the well, I should really put the centimeters in, I suppose, because it was in the question. And here I'm giving the exact value of sine of an angle, so I don't need any units on that. So that's the answer to all 3 parts of that exam question. Okay, I hope that was helpful. Take care.